Welcome to Zen Live TV. This is the Alien Scientist Science and Controversy Hour here on Zen Live TV. Today's broadcast, we're going to be talking about the case for anti-gravity, and I'm sort of going to give a summary of all the different anti-gravity videos I've put out and sort of where I stand on everything as of now, and sort of give a whole one place where you can find a summary of all the stuff that I've done on anti-gravity and a more up-to-date thing. And the term anti-gravity is probably what we'll start talking about. Of course, the views and opinions expressed on this program are not shared or necessarily endorsed by the sponsor or our shows or anyone involved with the Zen Live TV or the guests that I may have on from week to week. So keep that in mind. Lots of different controversial subjects discussed on this channel. Not everyone's going to always agree on everything. It's just the way it is. Anyways, today's topic we're going to be talking about is anti-gravity and sort of what I mean by anti-gravity. More so what I mean by anti-gravity now when I talk about this topic is sort of advanced propulsion. An advanced propulsion system, not necessarily anti-gravity, not gravity shielding or gravity manipulation or manipulation of gravitational forces in general. And we'll start with a little bit of discussion on some of the physics of why and the idea of gravitational shielding or anti-gravity may not hold as a reality in the universe the way it is constructed. And sort of why I've moved away from the idea of an anti-gravity or gravitational shielding device and moved more toward the notion of gravitational propulsion and technologies that would be used for propulsion technologies, energy in, propulsion out, basically. And of course, the fundamental laws of physics of conservation of momentum, that you have to have momentum is conserved, so you need to be shooting things out with a lot of momentum this way in order to propel yourself with momentum that way. So basically, the couple things about anti-gravity that I have come to see that will not work is first off, if you were to be able to create an anti-gravity machine that could shield gravity or move gravitational waves, sort of divert them around an object, you could basically use that to create a free energy machine. If I have this picture of a flywheel, this big giant flywheel. Big giant flywheel is basically a thing that stores up in rotational kinetic energy or rotational inertia. And the more mass is concentrated to the further out on the radius of the circle, so that way it has a higher moment of inertia, and or a higher what you call the I value in the equation. But anyways, if you were to build a gravitational shield over one side of this, and I have another picture with the flywheel free energy. Say we had a gravitational shield on one side of this flywheel, that you were able to take all the gravity waves that were affecting that side of the flywheel and move them around, so that suddenly that side of the flywheel would become lighter than the other side of the flywheel. So what would happen is that flywheel would just spontaneously start rotating, and you get just a constant rotation. There'd be a constant torque on this wheel, because it now would be unbalanced, even though it has the same weight. If you were to shield one side of that from gravity, you'd be able to, it would just start spinning, and you could basically build free energy machine just from that. And from everything we understand about the laws of physics, everything that experiments tell us throughout the 100 years of experimentation into physics, is that conservation laws are pretty much the ultimate laws of the universe, that conservation laws will never be broken, and that sort of this idea of this, that we could pull free energy out of something. If any time that this is looked at in physics, it always turns out to be wrong. It always turns out to be not true. There's no free energy, there's no free lunch anywhere in physics, and there's been zero experiments in accepted mainstream physics which can really say that we get free energy from somewhere. So another thing, I talk about free energy a lot, but free energy is essentially free from cost. That's a more appropriate term. Not free from the laws of physics, but free from cost. The laws of physics are very interesting. And as I talked about in some of my other videos, I believe it's all based on this idea that the universe came from nothing, so that nothing has to be conserved, because all the laws of physics are based on around conservation, that nothing can be created nor destroyed. Anytime you have something happen in an opposite direction, there's an equal and opposite reaction. Equal and opposite cancel out to nothing, so that nothing ever really happens. It's only relative to other things. There's nothing that can happen truly independently of itself. There's no such thing as a closed or isolated system, that everything is interconnected in the entire universe. And that all these laws of physics seem to be based from relativity. Relativity is just things are relative to one another, that they're not independent or events. They're always relative to one another. The speed of light's a constant. And all these laws of physics seem to be built around the idea that nothingness was where the universe came from, and nothingness is now conserved. So it's really interesting. It's really interesting that every time we come across an idea of free energy, it always proves not to work. There's conservation laws, there's laws of thermodynamics, and that all the laws of physics, from the way we understand them through experiments, which is the way that science is done, through doing experiments, not just making a guess to say like, oh, if I put a magnet in these arrangements, this will work. And time after time, there have been, I mean, you do find experiments online which are very misleading and sometimes show false or misleading results and stuff. But time after time, these people have been exposed as hoaxers and frauds, and it's really I really encourage people to really study physics and learn it from the mathematical rigorous basis of that which physics is founded on, because it's so easy to be misled with all the stuff and all the things on the internet. And I'm glad that I actually started making a lot of these anti-gravity videos when I first started learning about physics and was a freshman and sophomore in college. But I'm glad that I went and finished my degree and learned those rigorous mathematical formulations, so that I was able to really understand why certain things will work and why other things will not work. So I'm going to give you a summary of some propulsion technologies in this video, which have been related to classified programs in the past. A lot of these technologies are very poorly understood, or there's a lot of disinformation about them. And a lot of these technologies are real and can be used for propulsion technologies. But as far as anti-gravity goes, I just don't see it as an anti-gravity. Even the Podkletnov device, which was I've talked about a lot about this a lot. The idea of rotating superconductors, or even a superfluid, which is similar to a superconductor. The idea of rotating superconductors or superfluids, and using that to create an anti-gravity effect. Of course, it was first reported by Dr. Eugene Podkletnov, who's that Russian physicist. I was able to secure an interview with him and post that online. I have the full interview with that Russian scientist. And but there's been other reports that it could have been related to or discovered earlier, as far back as the Germans during World War II, with the whole lore of the Nazi bell, and all the books and literature that have been published about the Nazi bell and Yakov Sporenberg and the mercury-based plasma and the Zerum 525 or whatever they call it, that was used inside this Nazi bell experiment to produce either anti-gravity or a time machine. In some legends, it's been described as a time machine, and also in pop culture and stuff as a teleporter. In the game, I think it was Call of Duty Black Ops, they had a secret level in the zombies level where there was a teleporter. It was shaped like the Nazi bell and looked just like the Nazi bell and stuff. But anyways, if the Nazi bell was real, and there's lots of controversy over what exactly the Nazi bell was about, whether the Nazis did develop this sort of secret propulsion technology during World War II, or were at least working on it toward the close of the war in the secret facility in Poland, which apparently some Polish intelligence had gotten a hold of some kind of information about it and had it leaked or whatever. That, as the story goes, if you read up on this, if you can go on Wikipedia and look up Die Glocke, Dieglocké, you can read about this whole stuff. There's a lot of people that really hold this as truth and really believe this. This movie's been written about this sort of idea of a secret space program that branched off parallel during the close of World War II, during Operation Paperclip, when a lot of those German scientists and scientists from World War II were secretly brought to the U.S. and scurried away and brought to the U.S. to work on the U.S. space program, like Werner von Braun and some of the other scientists who developed NASA's original rocket technology, because they had worked on the V2 rockets for the Nazis. And but really, this is sort of outside of a lot of the bounds of for what a lot of aeronautical engineers that I've spoken with can actually believe as far as technology that was actually developed. And it's sort of interesting that this stuff really, it only first came out in like the late 1990s. There were very few people online talking about it, and then one of the first journalists who wrote about this was the Polish author Igor Witkowski in the year 2000, and he kind of really popularized it. And then Joseph P. Farrell and Nick Cook, of course, wrote a bunch on it, and Joseph Farrell's wrote several books about the Nazi Bell and the Nazi Wunderwaffe technology and stuff. So, but anyways, I just thought that was an interesting interesting thing that was worth mentioning. I've talked about it in the past, but really my whole thing from a scientist or an engineer or a physicist standpoint is really, I just want to know how this would work, like how this technology works. A lot of my videos have been on speculation about what was things different people have said about the mercury-based plasma that was used either in the Bell or in other craft. And I did talk about a little bit about that guy Edgar Fouché, who had come out with the whole thing about the TR3B working on this rotating mercury plasma. But I've since come to believe that he really just made that story up, because all of his technical specs that he talked about, the 65,000 RPMs, the 200,000 atmospheres of pressure, and the supercooling to 150 degrees Kelvin, as I pointed out in one of my other past videos, if you supercooled mercury to 150 degrees Kelvin, it would freeze solid, and it wouldn't be a plasma, it wouldn't be a liquid, it would be a solid chunk of metal. And so all of his technical specs made absolutely no sense. So it's pretty obvious that he made that up, especially with all the other things that we've caught him lying about, and just cornered him on so many things of his entire story that has fallen apart. I really don't believe there ever was a TR3B craft anymore. I think that he really made that whole thing up, because I've never heard any other whistleblowers or anyone else ever mention anything about a anti-gravity flying triangle, especially not a 600-foot platform one. But that's not to say that there isn't a effect going on with this rotating mercury-based plasma, or that the Nazi Bell could have been a real thing. Who knows? I'm not saying that. All I know is that the technical specs that I've got from him don't seem to make any sense, and I've gone through a lot of stretches of imagination to try and formulate this Zerum 525, or what could have been this mercury-based plasma that was purplish in color, and they had to keep in these lead containers. And there's a lot of very scant information that also that the Nazis were stockpiling thorium, and that thorium or beryllium peroxides could have been doped to the mercury-based plasma in order to give it special properties or something. But really, scientifically, it's really got to be about an effect, and a measurable effect that we could reproduce in a laboratory, because without that, that's not real science, it's pseudoscience. And it's not up to it's up to us to prove that this works through a scientific experiment and that others can replicate, rather than just saying that, oh, this works, now prove it doesn't work. No, it doesn't work like that. We have to go out and actually build this thing and prove that it would work. And I've talked with a bunch of people like Tim Ventura of AmericanAntigravity.com, and he's done a lot of research into a lot of these different same technologies that we're going to talk about today on today's program and stuff. And I definitely got to get him on as a guest sometime. I was supposed to have a different guest on today, and he canceled on me last minute. So I figured I'd do a review of all this stuff today, because as a lot of people have been asking me about it, and it's a topic I could really talk about for hours and hours. So I'd really like to spend the time today to cover it. But I apologize for not being more thoroughly prepared for this as I should be. But basically, the anti-gravity thing that I've looked at, the Nazi Bell stuff, I mean, there's scant details. There's really not much of intelligence value that I can really, or technical value that I can get from any of the stuff that I've read in the literature, or even Joseph Farrell's work. He does a lot of work into the history of the Nazis and things that were going on within German intelligence and high levels in the German Nazi government and stuff during World War II, at the close of World War II. But as far as technical details and really the science behind understanding more about how we could get this to work or replicate a sort of experiment that we could pull off in a laboratory or something, I haven't really gotten very far. What I have seen is the Podkletnov papers and the original stuff from Podkletnov, I think, is interesting. Also with the NASA replications that were done on the Podkletnov effect, that sort of said, oh, we couldn't replicate the effect, so we don't think it's real. And also some of the rebuttals or comments that were made about what went wrong with the NASA replications that were done at NASA's Advanced Space Propulsion Lab at Huntsville, Alabama. And my friend Frank Znidarsic, who's been a guest on here before, and we've talked about his theories on how this could work.
And we
also,
had a phone call, actually, but continue.
We have a phone call?
We did. We lost contact. We're going to go ahead and try and reconnect, and we will be right back. When we have the call, I'll just let you know.
All right, yeah, I'll
actually,
continue.
Wait, what was it? Yes, it is. Here we are. Ready?
Yeah.
Hello?
Hello, is this the live studio chat for the AlienScientist?
Yes, it is. Hold on one second. We're trying to connect you.
Okay. Can you hear me?
Yes, we
hello.
can hear you. Just hold on one second. We're trying to reconnect you. Hold on.
Thank you. Hello? Okay.
Hello.
Yes, we're connecting you as we speak.
All right.
Sorry about that. We have you online.
It's Skype. Skype's doing something weird, so.
You're telling them too much truth. That's what it is.
It's the government, man. They don't want this information out.
All right, are we connected? Hello? All right, 1 second. We lost him. We're going to get contact right now. Please continue. We'll be right back.
All right. Well, anyways, where I left off, I was talking about the Huntsville, Alabama replications that were done of the Podkletnov experiment. And Frank Znidarsic, who actually stood in and witnessed those replications, he was there, and sort of has his own theories on why they weren't able to replicate the effect and how he thinks it might work. And I think that's all super interesting stuff, and I'd like to get maybe a group together to do more experiments and get funding to really look into this more. I think it would be definitely a worthwhile effort, and that perhaps that we could succeed where some of the other groups have failed, or at least given the public perception that they failed, such as Boeing did. They said Boeing claimed that they were researching Boeing admitted that they were looking into the Podkletnov effect at some of their advanced propulsion sciences divisions. They were looking into this effect, but then they said, oh, we couldn't really replicate it or find anything about it, and they
Hello.
During the 1950s and 1960s with Thomas Townsend Brown, who discovered that asymmetric capacitors, when you charged things with electric current, that they either created an ion wind effect or some other effect that would cause them to lose their weight and actually become weightless or lighter than air. And so Thomas Townsend Brown worked for a number of years showing aeronautics companies and people these technologies. And what he found was a really weird pattern that kept happening. He'd show these technologies to these people. They'd say that, oh, this is interesting, but we're not really interested in it. But then they'd secretly open up, they'd secretly be doing research into this and doing wind tunnel tests and all other things while publicly denying that they were doing anything at all. Sort of a lot of classification kept popping up around this technology companies would publicly deny doing any research or having any involvement with it, but be secretly researching it and pursuing funding and even other things. Hello.
All right, we have the connection now. My apologies. We had a little bit of a technical difficulty, but your call is in.
Okay, great. Thank you.
Go ahead. You're live.
Oh, okay. So, AlienScientist?
Whatever you want to call me.
Oh, okay. My God, I'm watching you on the video feed here. Sorry, it's like a 5-second delay. My name is Ken Griggs, and I am obviously highly interested in what you're talking about with gravitational propulsion systems. But my own line of research is with quantum gravity, and my research advisor a couple of years back was Jim Gates from the University of Maryland. So this is the stuff that I do. And the reason why I'm calling is because I've admired your podcast for some time now, and wanted to engage you a little bit on what obviously what you're talking about, but in particular part of the reasons why we really haven't seen in the advanced propulsion systems when it comes to gravity at this point. And it's primarily because we really don't have an understanding of gravity on the quantum level, and I know you already know that. So I guess what I'm wanting to do is to put myself out there for you to ask questions to, but also, if you want to inform, your viewers that's the primary reason why, is because, you might say Einstein failed to a certain degree, and string theory hasn't really given us a lot to work with yet. And loop quantum gravity has some very interesting features to it, but it can't describe the actual matter content of the loop quantum gravity representation. So yeah, I mean, that's one of the things that I would love to talk with you about, with any
Awesome. This is
questions
quite
that you also might have. Mm-hmm.
This is a pleasant surprise to have someone like you call into the show, man. You never know who you're going to get when you start talking about, this kind of stuff, but that's awesome.
Well, and the primary reason is because you remind me of sort of an Agent Mulder. And I mean that insofar as you really try to find a scientific explanation or a rational explanation to a lot of the things that you're investigating. And in terms of obviously the conspiracy theorist world, that's just not a part of what you often see. And so when the truth takes you into a different direction, you go in that direction, and I admire that, because that's generally what we need to be teaching our scientists at this point. Most of the graduate students that I went to school with were a class of people who would cross the T's and dot the I's and not really ask questions beyond what string theorists or what their professors were simply telling them. They would just kind of go along with the flow. It's kind of our generation of folk, you might say. But we we tended not to be like the Richard Feynmans or the Albert Einsteins, who really would question everything. But we're at a stage again in quantum gravity, or rather in science, where quantum gravity demands that you question everything. What is space? What is time? What is matter? What is energy? What are those things? And so one of the prospects that I think a lot of scientists are finding is that, and you mentioned this earlier on, but there's this relational aspect that Einstein taught us with general relativity, but it's fairly much the notion that the only things that are actually going on are relational concepts. Beyond that, there's nothing going on. And so if that's what our science is leading us into, then we're having to find a mathematics like combinatorics that gives us the ability to describe relational phenomenon. Tensor theory and how Einstein came up with general relativity is a part of that. But the whole new mathematics of combinatorics is another major breakthrough from the 1960s that gives us this additional ability.
Yeah, with polyhedral combinatorics too, the whole different types of shapes and ways you can have topological connectedness, and
Precisely. And
yeah.
sorry. Well, and one of the sort of the tenets that underlies this stuff is exactly, again, what you said, which is the relational part of it. But it's the notion that measurement is really, you might call it a coefficient of a generating function. But measurement is an entirely relational phenomenon. And so the question becomes, do you have a mathematics that's general enough to describe structure and count the structures? So
Right.
the count itself of the structures is the measurement that you're performing, and the structure itself is the thing that you're measuring. And so that's what combinatorics gives us as a first principle tool. In fact, two mathematicians / computer scientists, one of them from Princeton, which is where I got my undergraduate, but is named Filoge and Sedgwick, and they came out with something called analytic combinatorics, which essentially becomes a mathematical foundation to using combinatorics and functional analysis.
Now,
And what they
sorry.
find, which is, sorry.
Excuse me. Yeah, I'm sorry. We're really gonna have to cut to a quick commercial. We will be right back.
Sure.
Do you mind holding? Is it okay?
Oh, absolutely,
All
absolutely.
right. Just making sure.
Quick
And
commercial.
we have to take a quick commercial break. We will be right back. The Alien Scientist. Make sure you stay here.
Stay tuned. This is going to be good.
Are you sick and tired of being sick and tired?
Yes.
Does the stress of daily life seem just like too much?
Yes.
Are you simply fed up?
Yes.
Do you wish you could just make it all chill out?
But how?
Well, then you need a Royale grinder. Royale grinder is a jumbo-sized 2.5-inch diameter premium 4-piece herb grinder that fits in the palm of your hand, with 50 closely interlined, everlasting chunky teeth that will keep on shredding whatever enters your chamber.
I can use it for all my herbs. Thanks, Royal Grinder. I'll never feel shitty again.
Order now at www.royalegrinders.com. That's www.royalegrinders.com.
Smoker and you need to quit, but you're discouraged cause it's harder than you like to admit. Baby, why plays paper? Baby, why plays paper? Are you a non-smoker but you like to do the tricks? Well, these are non-toxic Plains Vapors, located at 210 Mamaroneck Avenue in White Plains, New York. Visit our location and choose from a wide selection of exotic flavors.
All right, and we are back.
Okay.
So please continue with what we were talking about before, with the idea of that. Yeah, understanding quantum gravity, I think, will be the key to really new technologies that could be used for, if there is some sort of propulsion technology or way to manipulate gravity, it will be through understanding how gravity works on the quantum level, which is something we really don't understand yet.
Absolutely.
A couple things that I had thoughts or ideas about quantum gravity and some of the observations that I've heard from other people. One of the ideas was that sort of gravity could be caused through relativistic effects of just the particle inside a box bouncing off the walls, and that for instance, for an electron, you have a much bigger box, so it's not as much pressure on the walls, so it's a much lighter particle because of that. But in the case of a proton, it's condensed in a much tighter and smaller box. That you have more of a larger mass for a proton, even though just because of the relativistic effects of if you were to try to trap the mass particle energy in a box, and the sort of, I guess, the force or pressure that it would exert on the walls of the box as it bounced around and held inside, and that there's a calculation, I think, in it's on one of Frank Znidarsic's things that I thought was interesting. Is he shows that could be used to calculate the effective relativistic mass if you were to consider a point particle trapped inside of a box, and the relativistic effects of it bouncing off the walls. And of course, in a normal case of a normal proton or a normal point particle, that's anisotropic. It's bouncing off all the different walls randomly at any different time. But if you were to somehow compress that or control that so that it would only bounce off the walls in sort of a loop, and keep it spiraling in a loop, then you could eliminate potentially its gravitational forces in two directions, up and down, that by sort of compressing that box or changing it from a box or a sphere to a torus, say,
No, and it's definitely an interesting idea. I mean, sorry.
Right. Not to say that this is just theoretical musings. It's not saying this is how it would work or that this is even a correct theory. It's a guess.
No, and one of the things that has been a problem for modern physics is that essentially we, unlike Einstein and Niels Bohr, we haven't really been sort of holding on to an essential concept. We've been, for lack of a better statement, we've been pissing in the wind. And sometimes you hit your target, and most times you don't. And when you hit your target, you may not even know it. So the idea is to find this nugget, which is really what you're after, which what we're all after, but find this essential assumption about the universe that sort of lays clear, like saying the speed of light is constant and everything changes accordingly, but lays it fairly clear why these other things should exist the way they do. So, for example, your idea or Znidarsic idea of the particle in a box, and the smaller the box, the more energetic the particle. The more energetic the particle, obviously you have to include general relativity, i.e., gravity, in determining what's going on there, and eventually you'll reach a black hole. But what we've been certainly doing in string theory and in loop quantum gravity is asking that essential question that, when the energy of the particle becomes so large that you have to take the whole universe into account, because now the particle has become macroscopic, and now you can actually begin to ask questions about the particle sort of emerging as a macroscopic entity. And so this was one of the great changes that happened in the last 20 years in quantum gravity. where we realize you can't just talk about the small universe or the energetically small universe. You actually have to talk about the cosmological universe in describing quantum gravity. But
Right,
and
because
so
the rest mass energy of a particle. I read this other paper. I can link it to you afterward, but it's that the rest mass energy of a particle is the same as if you were to take that particle from the complete edge of the universe and bring it to that point from existence to the edge of the universe. It's the same.
Yeah, and that makes some sense, right? The beauty of what Einstein discovered, obviously, is that there is an invariant mass, a rest mass, a way of talking about particle physics that doesn't evaporate away, something we call the relativistic mass, but that there is a core structure to particles that quantum mechanics obviously utilizes quantum field theory as well. So it's a part of our general conservation principles. And so what we've learned, for example, is that the universe has what we call Lorentz invariance, which takes into account this rest mass conservation, but at the same time it forces us to include time in our calculations, and includes it in a way that the universe doesn't look Euclidean. It looks hyperbolic, or it looks Minkowskian, I guess is the terminology that's used. But in the end, that becomes a sort of another question. When you're asking about relationalism, when you're asking about how do I create a theory where things are only relating to each other and that's all there is, does Lorentz invariance come out? Does this idea of time naturally come out?
Right.
Do the degrees of freedom that we associate with space naturally come out? And
that's what I was more talking about. I was comparing the theory of everything to like the generating function for a fractal, where we're just studying the structure of the Mandelbrot set to try and formulate laws or matching patterns to figure out how it works. But maybe it's being generated by some other greater function, that these things just sort of come out in the mix and would appear things like Lorentz invariance and all the laws of physics, even electromagnetism.
And I have to say, what's really funny about that, now that you're sort of using the terminology of combinatorics, these generating functions, which just for your audience, again, a generating function is this polynomial where each of the variables like x or x squared or x cubed actually represent the structure, and then the number in front of that variable, like 2x squared or 3x cubed, the 2 represents how many of those structures are there. So you have something that's counting, and then something that it is being counted. So, for example, when you go to the casino, that's essentially how the gambling machines, how we can tabulate what they do. It's because they all have a generating function associated with them that, again, tabulates, is it going to be heads, tails, or is it going to be, 1, 2, 3, and then how many times is it going to come out that way? But what we find is that given this combinatorial way of speaking, there are some basic, and you can derive this whole combinatorial mathematics, and this is where Fallagier and Sedgwick, who developed analytic combinatorics, where that becomes so important, because from first principles, you find that there are objects that resemble space, or you find that there are objects that resemble sequences or time, and you find that there are other objects that represent mass. We call them cycles. And so almost from a primitive, most basic level, you can begin to derive things like relativity theory or things like quantum mechanics. Because again, these 3 quintessential structures that give you analytic combinatorics also match up almost perfectly with what we look for in physics, like space-time.
Particle physics. How about The
Mhm.
E8 Lie group, the thing Garrett Lisi did where he showed how particle physics can like come out of the E8 Lie group, just looking at it through
That's
different
right.
dimensions
That's
and stuff.
and so what we certainly glean from that from the outside is the idea of how important the role of symmetries are, which is also what Emmy Noether taught us in our conservation principles and in our evolution equations. But yeah, Garrett Lisi's work is quintessential in beginning to tie together all of these various symmetries of elementary particles. I think that the work of his name is Louis H. Kaufman is also extremely important because he's a mathematician who's been working with knot theory for quite some time. But he was able to, in fact, there's something called the Kaufman polynomial named after him. But the real essence of what he's also been doing is finding a way of using something called commutators in order to give you relativity theory, in order to give you quantum mechanics, namely Heisenberg's equations, and in order to give you electromagnetism. So of all of the work that I've studied, his is the one that seemed to come the closest to resolving most of our paradoxes of modern physics. In terms of coming up with a mathematical structure. For him, it was commutators, and demonstrating how do you get relativity theory out of it? How do you get quantum theory out of it? And then we find that the commutators, or the way that we do Heisenberg's version of quantum mechanics, looks like a generating function once again. And the commutators are serving as measurables on that generating function. There's a not so much involved in understanding what these various actors are doing, including Lisi, because by virtue of him talking about an E8 cross E8 group, he's also speaking to, in a richer way, he's speaking to what these other mathematicians have been working with. So when I'm mentioning Louis Kaufman, his work is very basic. It's sort of from first principles once again. Or when I'm talking about Falloget and Sedgwick and their analytic combinatorics, their work is from first principles. Lisi's work is not first principle. It's a guess. And it's a good guess. So he's sort of runs into the game at a much higher level. And now he's just trying to work it down to say, okay, wait a minute, is this really the group that's associated with elementary particles? And if that is the case, that the E8 by E8 is the actual symmetry group, why? Why that symmetry group and not something else? So inevitably he'll have to come, rattle his way back down to that fundamental question. Whereas these other mathematicians and mainly mathematicians are starting from the ground and working their way up and saying, well, wait a minute, if the universe has this core structure, then we should be able to derive, quantum mechanics, relativity theory, etc. So I find Lisi's work to be very, very inspiring. But what it does lack is sort of an Einstein principle.
Yeah, like a why, why is it E8? Why would it just be that?
Precisely. That's the critical question. Why would the universe choose that particular symmetry group over all other possible symmetry groups? I mean, let's face it, mathematics is subordinate to nature. Even if it seems like it's beyond nature, it's not. It's basically, if you assume that the universe is a computer, then the mathematics is just the logic and the structure that the computer is already using. And so I think that what we're, on that computer idea, what we're inevitably getting to is that is that these structures, these E8 by E8 or this SU3 versus SU2, there's the special unitary groups that describe elementary particles, but that structure comes about because the universe is actually acting as a computer. And this is the easiest, most efficient way of running the code on the computer. And that the code on the computer is a generating function, where each one of the polynomials, x or x squared or x cubed is just a different it's a different line of the code. And what each line of the code is actually running, the answer that it produces is the count. How many x's, how many x squares, how many x cubes. Those different counts are what we measure, and that's what the computer is literally the lines of code that the computer is actually running. What is it spitting out as an answer are each one of those numbers.
Well, wouldn't the universe itself be the line of code, and then it just gets plugged in?
Yes,
Generating
yes,
function.
absolutely.
Whatever the universe does to it at each point is the physics that are taking place. And I guess.
No, and that's exactly right. So the twist of it all is that the universe is the machine running the code, but the machine running the code is the code as well. So
Yeah.
it's sort of like this observer versus observed phenomena where that both of those things are there. But who are you? Are you the one being observed, or are you the one doing the observation?
Right.
So they seem to be two sides of the same coin, and in the end, all of it should be admissible to information science, because that's really what we're talking about, is the line. And by the way, this is the relativism that you were talking about originally. It's that, again, that whole idea that nothing exists in and of itself, that the existence of measurement, the existence of who and what we are, is a relational phenomenon. So we need observers to give us existence, and we need to observe them simultaneously. So part of the way of getting through that muck of which side of the coin are you on is by, hopefully, this idea of combinatorics, which also speaks to the idea of information science, because that's, again, what we're talking about.
And phenomenology, too, we're getting into.
Right, so phenomenology becomes the larger algorithm. So you've created an algorithm with either in your computer or with reality, and you're just running tests. You're trying to figure out how do different other aspects of reality work. There is a scientist, I'm trying to think of his name. He's got a twin brother. They're both working on quantum gravity, and what they've come out with in the last 10 years is a version that, what is his name? Okay, so the reason why I bring him up is because in their way of thinking, they believe that gravity is a concept that comes out on the macroscopic level. That on the quantum level, gravity doesn't exist the way we think it, the way we want to make it. And, we believe that in the quantum gravity world because we know that relativity theory does break down on the quantum level. So his idea is that gravity is emergent. And one of the methods of tracking the emergence or of qualifying the emergence is with I'm trying to think. It's a parameter that's used in the equations that it's a scaling parameter, essentially. It's something that, the larger you get, how can I put this? In thermodynamics, temperature is not a microscopic phenomenon. It's not what's really going on the smallest level. Temperature is a macroscopic, emergent phenomenon. On the smallest level, it's kinetic energy and the motion of the particle. So temperature doesn't make any sense on that level. So what this man is talking about is that shifting of your realities in terms of the scale in which you're taking your measurement. And so I point that out because that's how he gets relativity theory from a purely non-relativistic microscopic view of the universe. And I think that's also how we're beginning to see general relativity and gravity emerge as not a quantum mechanical. And what I mean quantum mechanical, what I'm really talking about is Planck scale.
Planck
so it's not
scale,
a Planck. Mm-hmm.
And then
it's
when
not at
you
Mhm.
have this sort of generating function on a Planck scale, and then when you zoom out to say, a million times to the level of 10
Precisely.
million times, then suddenly this bubble appears, which happens to look like general relativity, and that's
Precisely. That's what the belief system is
right.
going in. That's what we're thinking.
That's
yeah.
what we're going toward now, and I think that's the right
Mhm.
path to go in because of what we've seen about so much about group theory and about just like you mentioned about thermodynamics. We have this whole concept and notion of temperature, but then we look at experiments like they did with that. We found negative temperatures, and that
That's right.
forced us to reevaluate what we think of as temperature and how we identify in our terminology that we're using, because it's not, maybe that's an emergent property on the macro scale, but that's not really the physics that are going on.
But that's not really the physics. And that's the beauty right there, because if it's not really what's going on the smallest level, then like with statistics, like with entropy, there's always a way of getting what we never thought could exist. So as you're saying, like, a negative temperature, or like a negative entropy, or, a negative pressure that, we call it the inflation of the universe currently. But that's a negative, macroscopic energy that we don't seemingly aren't really able to account for in the particles that we've discovered. So yeah, that's the beauty of thermodynamics and the beauty of statistics, and hopefully it's what will enable us to trick nature, as it were, into doing things that nature doesn't normally do on the macroscopic level, like what your show was about. I apologize before I interrupted your show, but anti-gravity.
Yeah, the idea of a new type of propulsion, or a way to manipulate or control gravity, if there is one.
Precisely. And that's that part of the trickery right there, is that if, in point of fact, general relativity is a statistical phenomenon, a macroscopic temperature-like phenomenon, then maybe on the quantum level, which doesn't really work like that, on the quantum level, there's a trick that we can perform that gets us into a negative acceleration, or into a push rather than a pull of gravity. And then we exploit that. I mean, this is certainly the reason why we have HD TV and all of the electronics, is because not that man hasn't been, or humans haven't been around for a long time, but it's just that only in the last 400 years have we discovered what's really going on the really small level, and now we use that. We trick nature every day into letting us do what nature doesn't normally want to do.
Right. Send radio signals through the airwaves and
precisely
reinterpret them and do things with them that we would never have done if we didn't have the formulation of quantum mechanics.
You got it. And in fact,
those technologies.
Right, and we use that idea that we're able to get nature to do things that nature doesn't normally do, in order to look out at the broad universe and to go, hey, there's a civilization out there, because it's producing a repeatable pulse, in the radio wave spectrum. So obviously we assume that nature doesn't do that. So we use that to say, hey, they must be intelligent, or at least have some level of technology. And so, yeah, that's the trickery that humans have brought forth in the last 400 years. That we're able to distort nature to get it to do repeatable patterns that nature doesn't normally want to do. And so the idea of getting then nature to be tricked into giving you a negative acceleration or an anti-gravity seems to be something that we should be able to do. Simply because if we do understand quantum mechanics in a way at that Planck level, or at that non-general relativity level, then there's a good chance that we can, and then that's the work that I do, is to really tease out that that bit of fine detail, you might say, through generating functions, through counts, through what is gravity, what is mass, what is space, what is time, what is mass, and if you know what those actual structures are. And I mean structure in a combinatoric way. If you know what those structures are, then you should be able to tell me, for example, what acceleration is.
I understand that the conversation was explicitly awesome, but we have 2 minutes left, and I just wanted to make sure if there was anything else that you guys wanted to promote.
Well, I kind of wanted to mention real quick just a couple of the other things that I was going to talk about before.
So let's just cut the call off real quick. If there's anything else that you wanted to mention on the call, please let me know.
Coming on with me today. I'd love to have you on another week and get into this again, man. Please contact me on Facebook and let's do that.
Fantastic.
I'm going to wrap up the show.
Thank you for letting me interrupt.
Thank you. No, thank you for calling in, man. You made it much more exciting than it was going to be, honestly. So thank you very much.
Maybe next week. We'll get them next week.
I'm going to pen this down real quick.
All right. So
that's probably it for today, right? We got 2 minutes left.
Is there anything else you would like to mention, sir?
Well, just that we need to look at quantum gravity for the answers to whether or not there is some sort of effect going on here. I think that would probably explain if there is an effect that could be used to manipulate gravity, if there is one there. Otherwise, there are some interesting propulsion technologies that I've talked about: microwave beam propulsion, a lot of other things. I got some interesting videos that I'll link to in the description here if you guys want to check out some of that other stuff. But other than that, just stay tuned, and I'm gonna be interviewing more guys like we had on today, and trying to
Would you mind a question from us over here in the studio?
I'll take one from you guys real quick before I run out.
I really appreciate it. What about the sinkhole in Siberia?
I thought it was fake when I first saw it on Facebook. I'm like, oh, what is this? Some crap. But then I saw the video. I actually went and looked at the video and saw that. And, what we see above ground is nothing compared to what's going on underground. It could very well just be a chasm. I don't know if it's necessarily a portal to, the underworld or maybe a hollow earth, as some of the hollow earth theorists think that there's aliens living inside the planet and this is one of their entrances or something. I don't know. I really think that the sinkholes appear a lot. They're very common phenomenon. A lot of stuff. Water causes a lot of damage underground that we don't realize and we don't see. Because all that water flows downward and downhill, and it'll erode things underneath. Those freaking cars in that, what was it, the Ford or the Porsche factory where all those cars fell into that sinkhole recently? These things happen. The Earth's constantly changing, and it's not a, there's going to be earthquakes and things going on underground. I don't know.
Do you think it's like a pimple for the Earth's face?
Until we send a probe down there and really see what the heck's inside there, then I'm not going to hypothesize on what we might find. Maybe there's an alien base down there. Who knows?
All right. Well, thank you, sir.
Thank you. Thank you, guys. Have a good one. That's it. We are wrapped up for today.